Hey everyone, my name is Wei. Welcome to my channel. Today, we are diving into a comparison of three AI face swapping technologies: PuLID, InstantID, and IP adapters FaceID v2, all using a configure workflow. These three technologies are quite similar since they are all built on InstantFace, a deep face analysis library used for face recognition, face detection, and face alignment. InstantFace requires a license for commercial use. In terms of release order, IP adapter FaceID was the first to come out, followed by InstantID, and most recently, PuLID. Each of these programs needs a reference image of the face you want to swap, so the quality of the face swap heavily depends on the reference image you use. Let's dive into the comparison using a configure workflow. I'll put the download link for the workflow in the description below. I'll walk you through how to use it, then we'll generate 4 sets of images with the workflow and score them to see how effective each method is. Alright, let's get started. Once you've downloaded the nodes and imported them into ConfigUI, you might notice some nodes are missing. If that happens, just install the missing nodes through the Configure Manager and restart the ConfigUI. It's best to upgrade ConfigUI first. Otherwise, you might still encounter missing nodes even after the restart. Besides the nodes, you also need to install some essential models. You can find the download links and the storage paths for these models on the GitHub page for each node. I'll include the links in the video description below. For example, the PuLID installation instructions specify downloading the pre-trained models and placing them in the configui/models/PuLID folder. Some models will also download automatically the first time you run PuLID. Once everything is set up, we'll head to the configure interface. After importing the workflow, let's examine its structures from bottom to top. At the bottom are the nodes shared by PuLID, InstantID, and FaceID. They use the same checkpoint, prompt, dimensions for the latent image, and fixed seed, making it easier to compare the results simultaneously. Above that, you'll see 3 groups of nodes. From left to right, they are PuLID, InstantID, and IP adapter FaceID. The workflow author has organized them in a very intuitive way. This section is where the models are loaded and configured. After loading, the models are imported into the model inputs of the 3 key samplers. The VAE decoder then generates the image. Further up, right-click on the node named face. You'll see that it's actually a load image node, which loads a face photo used as a reference for PuLID, InstantID, and FaceID. Next, let's delete this irrelevant node. Right-clicking on these 3 nodes, you'll find that they are all saved image nodes, which display the final results. Alright, now that we understand the workflow logic, let's start generating images and compare the face swapping effects of these 3 methods. First, upload the face image. For this demo, I've chosen Scarlett Johansson, as her face is well known, making it easier to compare the face swap's similarity. This is purely for educational purposes and involves no commercial infringement. Next, we see that the numbers of the steps set in key samplers are only 4 because the preset checkpoint uses the lighting model, which generates images very quickly. The model parameters are already set for us, so no need to worry about them. Further down, the preset checkpoint here is the Dreamshaper XL lighting model I just mentioned. You can switch to other SDXL models if you prefer. The author chose the lighting model for quicker comparisons. The prompt is pre-written, but feel free to change it to whatever you like. The seed is fixed by this node. Let's go ahead and run this workflow. Oh no, it's running into a lot of problems. ConfigUI has marked the problematic nodes with red boxes. So let's check the terminal for more details. The terminal also lists all the issues. First, the load image node might have a preset checkpoint name that doesn't match my dream shipper. Let me reset that. Second, there's an issue with the InstantID node loading ControlNet models. There's also a problem with this node loading the LoRa for FaceID. Moving up, we see the seed inputs of the 3 key samplers unconnected. Let's connect them to the seed everywhere input. That should fix the problem. Now, click on the Q prompt button. We see PuLID is up and running. The key sampler is already generating images. The first image is now available. Let's reposition the saved image nodes side by side for easier comparison. The IP adapter FaceID is also generating images. The second image is out. Finally, the InstantID images are coming out. From left to right, we have images generated by PuLID, InstantID, and IP adapter FaceID. Let me zoom in a bit so you can see them more clearly. Which one do you think works better? One set of pictures might not be enough to compare the effects, so I switched to the albedo-based Excel model and generate 4 more sets of images. Let's score them and compare their effects more precisely. I've set up 4 dimensions. A prompt fit evaluates whether the generated images match exactly what the prompt describes. The face luminosity assesses whether the lighting and the shadows on the faces are natural and match the surrounding ambient light. The face similarity measures how similar the generated images are to the reference face image. The face detail looks at the texture and the richness of the details on the faces. For convenience, we'll use the score of 1, 2, 3 for each dimension. Let's enjoy the comparison with some beautiful music in the background. Here's the final scoring grade. Overall, InstantID is the most effective of the 3. FaceID comes close, and both are much more effective than the new PuLID. However, while InstantID works the best, it also consumes the most resources to run. So, there isn't an absolute best. It depends on your specific needs. These scores reflect my subjective opinion. I encourage you to test it yourself and share your thoughts in the comments section. If you enjoyed this video, please like and subscribe. See you next time.